All right, here we go. The volume of a sphere, and it's up on the board on those charts, is 4/3 pi r cubed. We also need to know in this lesson the surface area, which is 4 pi r cubed. Okay? So the two things that we need to know is the volume of the sphere is 4/3 pi r cubed. R times R times R is R cubed. And then the surface area is 4 pi r squared, not cubed, Mr. Bierschbach, squared with a 2. Okay? Those two formulas are what we're going to use today. Okay? So here we go. The drama club makes a big ball of foam to hang above the stage for play. They plan to cover the surface of the ball with a metallic fabric, so it looks like a disco ball. What is the minimum number of square meters of the fabric that the club needs? Okay, so we'll go through this. Well, we know the volume of the ball is 1.8, but to figure out the surface area, we need the radius. So we have to work backwards. Okay, so we set the volume equal to the formula. Volume equals 4/3 pi r cubed, so 1.8 equals 4 pi r cubed, or 4 pi r cubed, yep. So if you multiply each side by 3/4 and divide it by pi, and then you got to take the cube root on your calculator. Okay, for those of you who don't know how to take the cube root on your calculator, you're going to get an answer somewhere on your calculator. So I don't know what, somebody take 1.35 divided by pi once and give me like 7 decimals. 1.35 divided by pi. It's going to be 0.42. Okay, now that's what r cubed is equal to. To figure out what r is equal to, you take the answer and then you do that caret symbol and then you do 1/3. Okay, you do the caret symbol and 1/3 to figure out what the radius is. Okay, so if you take the cube root of 0.42971, you should get somewhere around 0.75. Okay, and then that's what the radius is. But they want to know the surface area, how much fabric it needs to cover that ball. So then you take this, plug it in for the radius of your surface area formula, 4 pi r squared, and you get 7.1. Okay, so we're going to do that for this. Okay, all right. Nope, we're not going to do exactly that. We're going to just do the opposite. Okay, now here's a sphere that's covered by 6 square meters of fabric. Let's find the volume now. Let's go the other way. How do we find the volume? Well, the surface area is 4 pi r squared, and they tell us our surface area is 6. How do I get r alone? First step, divide by 4. Pi r squared equals 1.5. Then what do we do? Divide by pi. Somebody give me about 4 decimals here. 1.5 divided by pi. 0. Thank you. And then we have to take the square root of each side. So what is r going to be? 0.077, somewhere around there. Somewhere around 0.77. 0.7 what? 0.690. Let's go 0.69. Okay. All right. That's what the radius is. Now I need to find the volume of the sphere, which is 4/3 pi r cubed. So you take 4/3, you're going to press your pi button, and you're going to put 0.69 to the third power. What's the volume of that sphere? 4/3 times pi, so that's going to be a little over 4 times 0.69 cubed, which is going to be a pretty small number. So it's going to be a little over 1, right? What is it? 1.4 meters cubed. Okay, there you go. Percentage. Okay. Now, here's a sphere inside a cube. Okay, if the sphere has a radius of r, what's the length of the cube? If from here to here is r, what's the whole length of the cube? Well, if this is r, how many r's are down here? 2r. Okay, so this is 2r, and a cube is the same on each side, so it's 2r by 2r by 2r. So the volume of the cube equals 2r times 2r times 2r. What's 2 times 2 times 2? 8. What's r times r times r? R cubed. So that's the volume of the cube. Now we need to know the volume of the ball, which is 4/3 pi r cubed. Somebody take 4/3 times pi, please, and give me a decimal. 4.2. So that's 4.2 r cubed. Okay? Now, to figure out what percentage of the cube is the sphere, you have to put the sphere volume over the cube volume. What happens to our r cubes? They cancel. So take 4.2 divided by 8. What's 4.2 divided by 8 to 2 decimals? 5.3. So it's 53%. 53% of that cube is the sphere. So then it's 47% dead air space in there. And you go, I'm never going to have to worry about that. Well, guess what? It's going to be on your test. Something like this. So you will have to worry about this at least one more time. A couple more times. Okay? So, empty space. Okay? That's what we're looking for. Now, if the volume of a sphere is 4/3 pi r cubed, what's the volume of a hemisphere, a half of a sphere? It's not up there, but if you think, you should be able to get it without much of a problem. What's half of a sphere, half of 4/3 pi r cubed? What's half of 4? 2. So it's 2/3 pi r cubed. 2/3 pi r cubed. So it's 2/3 pi times 4 cubed. 4 times 4 times 4 is 64 times 2 is 128. So it's 128 times pi divided by 3. I would say around 140. What is it? 134. There we are. Okay. Volume of a hemisphere. If a hemisphere has a diameter of 13, what is its radius? It has a diameter of 13. What's the radius? 6.5. So 2/3 pi times 6.5 cubed. 6.5 times 6.5 times 6.5. That's a little over, that's almost 250. So, yeah, it's around 200-ish. Oh, 270 what? 274? Okay. All right. Let's say we have this is full. Okay. It looks like a silo for those of us who are farmers. Okay. An old silo. Let's say filled to the top with corn silage. Okay. How much corn silage can fit in that silo if you fill it way to the very tippy top of that? Okay. So, and let's say the density is 100 kilograms per meter cubed. So the volume equals, for the top, 2/3 pi r cubed. For the bottom is a cylinder. It's the area of the base, which is pi r squared times the height. So for the top, 2/3 pi. What's the radius? 1 cubed. So it's 2/3 times pi. What's 2/3 times pi? 2 point. Give me one more decimal. 2.09. Thank you. So the volume of the cylinder is pi 1 squared times 3, or 3 times pi, which is what, 9.28? No, it's not 9.28. 9.42. There we go. If we add these together, we get 11.51 meters cubed. Now, if the density of solid is this many kilograms per meters cubed, we get rid of the meters cubed by multiplying by 100 kilograms over meters cubed. The meters cubed cancels. So that times 100 is 1,151 kilograms to the nearest kilogram. Okay. Hey, another dead air space. Except for this time, the ball is in there, and there's a little space above the ball and a little space below the ball. Okay? A little space above the ball and a little space below the ball. Okay? What is the height of the cylinder? If the height of the cylinder is equal to the diameter of the sphere, oh, so there is not space above and below. What's the volume of the space between the sphere and the cylinder? Okay? So the diameter is 24. Because if the radius is 12, the diameter is 24. So it's 24 up and down. And we want to know the dead air space. Well, if the volume of the sphere, which is 4/3 pi r cubed, and the volume of the cylinder, which is pi r squared h. Okay? So, calculator, 4/3 times pi times 12 cubed. Should be a pretty big number. Over 1,000. Probably over 2,000. Maybe over 2,000. I don't know if it's over 2,000. 4/3 pi, 12 cubed. What do we get? 7,238.2. Pi 12 squared 24, and that's even going to be bigger because the cylinder is bigger than the sphere. So if you take 7,238.2 divided by 10,800, ooh, wait. What is the volume of the space between? You're going to not divide them. You're going to subtract them because we're not finding a percentage. We're subtracting them. So it's going to be 3,619.1. Okay, that's it. That's the basics of what we're doing today. Some of the problems are difficult. Work together. Try to brainstorm a little bit. If you need my help, I'll help you out. You have a good half hour or so to work on this. Tomorrow, I will be gone. Okay, tomorrow I will be gone. So be nice to Mrs. Bloom. You'll get a worksheet to get ready for the test on Thursday. The test is not Tuesday. The test is Thursday. We'll go over everything on Tuesday, go over that worksheet really well so we kind of know what's going on for the test. And then Thursday, you'll take the test next week. Okay, there you go. Yep.